would have helped to been on mute. I thought y'all were just ignoring me. Got it. I will throw this in our other channels as well while we're waiting. Hello, everyone, and welcome to March webinar. And I am our community and volunteer. So excited to welcome you to another edition, another month of Webinar Week. So each week we set aside a couple of days to pull in our expert mentors on a topic of their choice or a topic that you're interested in, pick their brains for a bit, have presentations, live conversations, guest lectures. We're really excited to kick off this series with Dave Muirhead, who is going to bring to us an Elixir Basics webinar. So a little bit about Dave before we kick off. Dave is a partner in Blue River Systems Group, a consulting firm that helps forward-thinking software product companies and IT organizations build custom software solutions on the Elixir and Java platforms. He has been developing for 27 years in a variety of languages, including Smalltalk, Lisp, Scala, Prolong, and Java. After spending 20 years building software on the Java platform, he discovered Elixir programming language in 2019 and has never looked back. Dave lives in Mount Pleasant, South Carolina, and is a mentor here with SC Codes. Please feel free to connect with him after the webinar on LinkedIn or on the SC Codes Slack workspace. If you'd like more information on that, I'm happy to answer questions in the chat on how to join our workspace. And speaking of our workspace, for those of you who are not familiar with SC Codes in general, welcome to you as well. We are a free platform where residents across South Carolina can join, learn coding skills, different languages, connect with experts in the field, all totally free with the goal of helping you build your toolkit in order to start a career in developing. So we're so excited again to welcome you to our webinar week. Please head over to our events page at the end of this webinar to check out some of the other events that we have going on this month, as well as to stay in the loop with our future webinar weeks. And with that, I will turn it over to our speaker of the evening, our guest lecturer of the evening, again, Dave Muirhead.
All right, thank you, Morgan. Yeah, I'm excited to be here to tell you about Elixir. It's something that I discovered, a year and a quarter, 2 years ago. And it's been an eye-opening experience and a breath of fresh air. So I'm pretty excited to tell you about it. I think there's some good prospects there too. So I'm going to share my screen and we'll get started. Sorry, that's my phone ringing. Okay. Can you see my screen? Okay.
Yes.
All right. So just by way of quick introduction, I won't repeat what Morgan mentioned, but we've done a lot of work for both software product companies and IT organizations and built a lot of software, a lot of it on the Java platform, more recently on the Elixir platform. I put a couple of bullets here. Two of them are product companies, Synexus and Rally. Rally, you might recognize, it's one of the agile tools that's out in the marketplace. That's an example of one of the software products that we built. And then this other little list here of Johnson & Johnson and Target and so forth, those are IT organizations. And I'll loop back to why that's relevant later on. But let's just kind of jump in. So from an agenda perspective, what I want to do is kind of give you a bird's eye view of Elixir, what it's about, who's using it, those kinds of things. And then I want to set a bit of context about why is it important or relevant to talk about Elixir and its ecosystem. What's the big idea behind Elixir? And then we'll go through some of the language differences with other languages, some of the features that the language has. Though if we have time, we'll go through a bit of a ecosystem survey, like what are the tools and libraries and stuff that you can use with Elixir. But I do want to save time for a demo at the end of something called Phoenix Live View, which I think you'll be interested in. So let's get into the first section, bird's eye view of Elixir. So Elixir is a programming language. It's a dynamic, functional programming language, and it's described as being for building scalable and maintainable applications. It runs on something called the Beam, which is a virtual machine. It's the Erlang virtual machine, and I'll kind of get into what that is. But that runtime system is highly regarded for low latency, distributed, and fault tolerant systems. So Erlang and the Beam, which are the underlying technologies under Elixir, were invented and created by a Swedish networking and telecom company called Ericsson back in the mid 80s. Elixir, the language, was, I think, originally created by a guy named Jose Velim in like 2011, but really it's been getting a lot more traction in like the last, few years here. And Elixir is used in a lot of different places. So it's used for web development, embedded software, data processing and ingestion pipelines, and a lot of big IT shops and so forth, multimedia processing, things like that. So we'll talk more about those as well. But who's using it? Well, here are a few icons or logos of companies that you might recognize that are using either Elixir or the underlying technology, Erlang. So, WhatsApp and WeChat and Pinterest and Discord, Bet365, which is an online sports gaming product. So there's a lot of companies using it, and a lot of startups and small and medium-sized businesses are starting to shift in that direction. So why are people interested in Elixir? I mean, and here's just a few anecdotal reasons. I think we'll talk more about like really why, but these are some of the results that different companies have seen. So I'll just let you sort of scan the list there, but significant ones like Discord being able to increase the scale of their application from 5 to 11 million concurrent users. WeChat has 300 million daily users that they have to support. And WhatsApp, they built their system on Erlang, and it serves up to 900 million users, but they only have 50 engineers. So that's pretty amazing that they can get that much software value out of so few number of people. So what is it good for? I think generally Elixir is a good choice for mostly server-side systems, although we'll see where maybe that's starting to change a bit too. That have certain kinds of requirements. So like high availability, meaning that the system has to be up all the time. Low latency, meaning that it has to respond in a very short period of time, like soft real-time requirements for things like chat or video systems and things like that. High levels of concurrency, where there's a lot of work that needs to get done at the same time. Huge scale, those are things that are web apps and other kinds of applications that require a large volume of users at the same time. And then also, where you want to use cloud resources or just other computing resources efficiently. So that can include web apps and embedded systems, Internet of Things applications, a lot of different kinds of systems. Elixir may not be the best choice for systems that involve, high single core performance, where basically maybe you have a CPU bound task, like some real number crunching operation you have to do that's just taking over the processor and having to just do a lot of hard processing. That may not be the best choice for Elixir. Hard real-time systems like sensors in aircrafts, digital signal processing, anti-lock brakes in cars, things where the failure to respond in a certain period of time is life-threatening or something like that. Those are typically built in other kinds of languages. So I think Elixir is great because it has a supportive community. I think the people in the community are really welcoming. They're very helpful. Like on all the forums and stuff, they'll answer your questions, and they're very accommodating to people that are learning. There's a lot of really great libraries and so forth out there that you can leverage. You don't have to build it all yourself. There's a growing number of conferences. I think job prospects are good for Elixir developers. There's not as many of them as there are in a lot of other languages. And frankly, I think just there's a lot of happy developers breathing sighs of relief because building software on the Elixir platform is a lot of fun and a lot less of a pain in the neck than it is on some other platforms. So before I dive into Elixir, I just want to sort of set the context for this presentation. So, everybody knows that, the web is growing exponentially. Applications are getting bigger and bigger and require more resources. The world in general, but the web certainly is concurrent. There's lots of things that need to get done simultaneously. We all know that networks fail, programs fail. We have, network outages, things like that, denial of service attacks, all those kinds of things. And the other thing is that the clock speeds of our computers are really not getting any faster. What the manufacturers of computers found out, and chips found out, is that actually by dialing back the clock speed or not increasing it more, you can reduce the amount of heat that's generated, and you can actually run more cores on a processor and get more throughput. But that's really only true if you can run your software in a concurrent fashion, where you're really running pieces of the software basically in parallel across those cores. So we really are looking at a world increasingly where you need to add more cheap, power efficient, but multi-core machines that allow us to do all of this kind of processing and handle all this load and so forth. So computation will be more and more distributed across machines. I mean, it's just unavoidable that for many kinds of applications, there's just going to be multiple machines in the game, and you have to cope with that situation. So I want to engage you in an analogy, and you'll probably think this is ludicrous, but I think it makes the point. So, how is Elixir different, or maybe even better in some ways than other single-threaded languages like JavaScript, or even multi-threaded languages like Java? Multi-threaded languages being ones that you have the ability to run things in code in parallel. Well, so let's think about something we all know and love, which is email. I mean, if you think about email, basically email is a system where we send each other messages, and each of us has a mailbox. I mean, let's just assume, for the sake of the analogy, that we don't have 40 mailboxes like we all do. We just have one mailbox. I send you a message, you receive it in your mailbox. At some point, you're going to do something with it. If you send me a message, at some point I'm going to see your message. So we just have this sort of message passing system where I send you messages, they arrive in your mailbox, and you send me messages, they arrive in my mailbox. Well, what if the way email worked was when I send you a message and I ask you a question and it arrives in your mailbox, what if I couldn't go on with my day? What if I couldn't do any other work? What if I couldn't, send any other emails or make any phone calls or do anything except just sit there and watch my inbox for you to reply until you got around to accessing that message? And you have to go through your messages in order that they arrive. Let's say you finally get to my message and you do whatever work it is or answer whatever question it is and send me a message back. Think about a world where all of us are basically sitting at our desks watching for emails to come in. The last email that we sent, we're waiting, and we can't do anything until we get a response. That obviously would be a world where not a lot of work is getting done. So, in reality, if you think about it, email systems are highly asynchronous. I send you a message and then I go on with my day. I wait for, eventually I get notification back by way of a message in my email box that says that you've answered my question, and I can go in and look at it, and maybe I can then pick that task back up and go do some more work and send another message. So one is very blocking. One is, the first one is where everybody's waiting for everybody else until somebody gets work done, and then I can continue on. It's all happening in sort of a serial fashion. And the other one is a much more asynchronous kind of a world where everybody continues to work on things even when they're waiting on an answer. And that's kind of the big idea underlying Elixir, is that it allows you to build software in a way that you don't have a lot of blocking going on. So in a lot of languages, including Java and various others, there's a lot of blocking that happens as I interact with parts of my program, interact with other parts of my program. It can be sitting there waiting for answers until something is computed before it ever moves on. So there are times, in fact, there's quite a lot of time where the processor can actually be sitting there idle because the work is being done in a database or wherever it is, and I'm basically waiting on an answer and really can't continue on. That's how a lot of programs are built. They're built as if they were these email systems that just sit around and wait. But what we really want, if we want to suck up all the resource on the computer, is to be able to do work in parallel. So this is where I want to dive into the Elixir language overview and start with a topic called process-oriented. So basically, Elixir is process-oriented. So you've heard about languages that are object-oriented or whatever it is, but I would say Elixir is process-oriented because basically the primary organizing concept is one of processes communicating via message passing. So this is what many people refer to as the actor model, and I'll explain what that is. But remember the email analogy as I talk through what the actor model is. So there's this thing called the actor model of computation that this guy wrote a paper about, and in truth, with Elixir and the language or the platform that underlies it, which is called Erlang, this all kind of existed before this guy ever wrote the paper, but these days we call it the actor model of communication. And what it basically boils down to is an actor is basically a completely isolated unit of computation. In Elixir, that's regarded as a process. An actor has a mailbox in which it receives messages, just like we have email boxes. An actor processes messages received in its mailbox sequentially, so it never jumps over them or anything like it. It just basically goes through them sequentially. And the implication of this is that even though we have all this inter-actor communication that represents concurrency and just interactions, they're inside an actor, there's really no concerns about concurrency or threading or locking or any of these complicated things. Everything's sort of happening sequentially inside the actor. When an actor gets a message, it can basically do a few things. It can create more actors. It could send a message to another actor. It could change its state. So it might be holding on to some count or some value, and it might, in response to receiving a message, update that value from 10 to 11 or something. The other thing about actor systems is one actor is no actor. They come in systems, and it's not uncommon to have thousands of actors in a application, hundreds of thousands, sometimes more than that. Okay, so remember I was talking about the analogy, and now I've told you about the actor model, and I've said that there's this thing called a process in Elixir. And so what do I mean by a process? I mean it's an actor, or it's an isolated unit of execution. It's some piece of code basically that's executing, and it's doing some work. Okay, and so I don't mean like your software development process or anything like that. I mean actual work being done on a computer in the program. Elixir gets its process model from Erlang, which is this underlying technology that it runs on top of. Just like all languages compile down to something, some form, and then run on the machine. Elixir compiles down to basically Erlang, effectively, and runs on this thing called the Beam virtual machine, which is basically almost like an operating system for applications. So Elixir processes are not operating system processes or even threads, if you've heard of the notion of threads in a programming language. Basically, each Beam VM runs in a single operating system process, which is an expensive kind of heavyweight resource on a computer. And then inside of that VM are all these thousands and thousands and thousands of processes, each one representing some work that could be done, for your program. And the Beam basically does the work of scheduling your processes to do work actually on the cores of the underlying computer system. And it uses what's called a preemptive scheduler. So another difference in other virtual machine technologies like the JVM and so forth is you may not have a preemptive schedule. You may have a scheduler that basically allows a particular process to just do as much work as it wants, and when it's finally ready, sort of give up the processor to some other thread or some other process. In the Beam, they're preemptive, meaning everybody gets a fair share of the processor. So there's no possibility for a given process or program or whatever to just sort of take over the processor and starve everybody else out of CPU resources. And that's a pretty important aspect of this. These processes are just like super lightweight, almost like data structures that they can be spun up or down in microseconds. They're completely isolated from one another, and that's a significant point I'll come back to, a couple times. But basically, they share no memory, and that's one of the things that's really different about Elixir and this technology versus, say, like multi-threading in Java or something like that, where you can actually, share state and share memory, which puts you in the position of having to very carefully make sure that you don't have two processes that are basically going to try to update the same piece of information at the same time. And to prevent that, you use things like locks or mutexes or semaphores or these other concurrency controls. But in Erlang and Elixir, there is no sharing of memory. There's really sharing of nothing between these processes. So you don't have to worry about that stuff. And furthermore, the garbage collection is on a per process basis. So in a lot of these languages, you're always creating data, objects or data or whatever. And sometimes the data that you create is held onto and used by the program for a long period of time. And sometimes it's just, used to like calculate some value, and then you're done with that data. So they have these things called garbage collectors that basically manage the memory that the application is using, and they go clean up any of these dead objects that are no longer used. And garbage collection in Java, for example, can be a really painful thing if you have a process that's doing too much garbage creation. You can actually get these garbage collection pauses where every thread in the virtual machine is not terminated, it's suspended basically while the garbage collector does its work. And that means that your application stops working while the garbage collector is doing its work. In Elixir, garbage collection is on a per process basis, so you never have these stop the world garbage collections. And like I said, since we don't have to share memory and we don't have to worry about other processes stepping on our data or whatever, it's a lot easier to reason about how my code is interoperating with other people's code. It's just easier to develop and easier to understand. Processes run concurrently, so you have many of them working at the same time. So what's the effect of all of this? These isolated and concurrently executing processes? Well, basically what it boils down to is you have better scaling potential. You can build bigger, stable applications that saturate all the CPU cores on every machine. You have more work getting done per machine because you're not wasting CPU cycles sitting around and waiting. And that actually turns out to be pretty important in the cloud environment because cloud resources are really expensive and we have more and more work needing to get done. And so we have to be really efficient with the resources that we have. The other effect of this is you get better fault tolerance, and I'll talk about what fault tolerance is. But first, scalability. That's about how well an application can grow to handle increased workloads without sacrificing things like response time and throughput. So response time is like how fast does it respond to a user request. Throughput is like how many requests can I handle in a given period of time. And concurrency is this idea that an application can process 2 or more requests at the same time. So there's a couple ways you could get scalability. I mean, variety of ways, but like you could start 4 different instances of your application on one machine and like 1 per core. Or you could start 1 instance of your application that's capable of using all the 4 cores. It turns out that starting 4 instances of your application, 1 per core, is a lot more resource heavy and more complex. So you'd really rather do the second item, which is start 1 instance of your application and use all these cores. So that's what actor-based process models allow you to do. You basically allows you to saturate and use all of the cores and run a lot more things in concurrency and run them together. So There's no blocking and waiting, there's no idle cores. And that means that you can increase the scale of your application by just adding more machines without drastically increasing the complexity. I can basically run another instance of my application on another machine, and I get all of the resources of that other machine totally used up by that application. A bonus in the Elixir world is that built into Erlang is the ability to run many instances of your application in what's called a cluster across a number of machines. And Erlang takes care of making it seem to you as a programmer as if basically all those machines were one single machine. You can just deal with processes as if they were local to you. So what does scalability mean in the real world? These are some examples. Pinterest, has 30,000 events per second, and Discord, millions of events per second and all this kind of stuff, 5 million concurrent users. A lot of internet traffic, like 90% apparently goes through routers and switches that are controlled by Erlang. That's a pretty major scale. So that's what scalability means, and Elixir gives you that capability. Another thing is it gives you fault tolerance. So fault tolerance is basically the ability of a system to stay running and to deal with errors. Like what happens when some part of your program crashes? Does it take the whole system down? Does the rest of it continue running? What is the effect of a crash? And because Erlang processes and the Elixir processes run entirely isolated from one another, it has the ability to basically localize and limit the inevitable errors that are going to occur. And there are examples of systems that have been built with primarily Erlang, but I think also Elixir, that have really been running without interruption for years. Like they're pretty much up all the time. And the reason why is because they never crash. And how do you do that? Well, you have one approach, which is called defensive programming, which is where I basically spend a lot of time and energy trying to prevent crashes in the first place. Or you can take the other approach, which is detect, handle, and recover from crashes. And that's really what Elixir does. And the mechanism for that is what's called a supervision tree. And supervisors are basically these processes, like other processes in Elixir, but their only job is to supervise other processes, like the ones that you write that do your work, and to restart them in a known good state if they crash. So basically, if an error occurs in one part of the system, it's not going to crash the entire system because there's going to be some supervisor that's supervising the processes that are in that part of the system that crashed, and it's going to handle the situation. And the rest of the system probably will never even know, and it will just continue to march on. And that's very different from the way most programming languages work and programs work. So supervisors are these guys that are basically responsible for the whole life cycle of these processes. And so like the question becomes, well, who supervises the supervisors? And well, the answer is supervisors. And that's why it's a hierarchy, it's a tree. And these green guys really kind of represent like the code that you write, the processes that are instances of the code you write. Basically, the supervisors are the ones that are responsible for keeping them running. So a supervisor can restart a process a bunch of times, but what if the supervisors crash? Well, the answer is they were written like 20 years ago, and they are comprehensively tested. There probably aren't any bugs in any of the supervisor libraries. So those supervisors are highly unlikely to ever crash, and that means that applications built on this platform are extremely fault tolerant because of this mechanism. So I want to move on to some of the actually sort of language level stuff before we look at some demo. Elixir is a general purpose programming language like Java or C++ or Perl or Python. It's suitable for solving a lot of different kinds of problems in almost any application domain. There are other kinds of languages that are called special purpose or domain specific programming languages, and they're designed for a specific purpose, like SQL, for database definition and manipulation, or R for statistics or whatever. But Elixir is general purpose, so you could use it for lots of things. Elixir is functional. It's a functional language. You've probably heard that term. And that means that your programs are composed of what we call pure functions. that are organized in modules. So basically a function has an input and an output. The same input always produces the same output, and there's no side effects, meaning like inside the function, you don't have things changing that, are separate from what comes out of the function. The other thing is that in Elixir programs and functional languages, data is immutable. And that seems like, well, okay, great. If data is immutable, like how do I ever get anything done? And the answer is by way of functions. And basically a function is allowed to copy arguments and calculate new values, but it never can mutate anything. So you can basically use functions to transform an input into a new output. And that's how you can get work done. You can create modules that are namespaced and sort of organize your code in functional languages as well. Let's see, let's keep going. Functions are first class, meaning that you can actually pass them as data. Like I can make a call to a function in Elixir and pass a function as an argument. That they can also be returned from a function. So that's a useful construct in a lot of cases. They're also named, but can be anonymous. And so here's some of our first Elixir code. We have this little module called greeter that has two functions, hello with a single name and hello with two names as arguments. And we can refer to those functions by their name and their what's called arity, of the number of arguments that they take. So hello/1 is the function that just takes the single name, and hello/2 is the one that takes the two names. We can have anonymous functions that basically do the same work as those name functions. Those are the ones at the bottom, hello1, and then the syntax, with this fn and a parentheses and the arrow and so forth. That's basically just the syntax for a anonymous function, one that takes a single argument and one that takes two arguments. Elixir is also a dynamically typed language. So type checking refers to this process of sort of making sure that the values that you're using work together and that you're enforcing this the type constraints that you want. So here's this example, like count equals 10 plus a string burrito. You would expect that to crash, and it would crash. It's just that in a dynamically typed programming language, you only do type checking at runtime, like really on the fly as the program executes. So in a language like Smalltalk or Elixir, you're not going to catch that error, count equals 10 plus burrito, until the program actually runs. In a statically typed programming language, you would actually be able to catch that at compile time, before the program even starts running, because you have this type information, like that the variable more down there at the bottom is of type string, and the variable, and 10, the literal 10 is an integer, and it's not valid to add 10 and a string together, so the compiler would be able to flag that. So dynamic typing is great for some certain reasons, and it has certain disadvantages. Elixir happens to be a dynamically typed language, but it does offer a way to add type information if you choose. So there's a couple ways you can do it, but basically, like in this case, at the bottom here, there are these things called specs, function specs, where you'll see the little @ sign and then spec, and then basically like add number, comma number, double colon, and then in curly brackets number colon string.t. That basically says this function is named add, and it takes two numbers and it returns a number, actually a tuple, which is a number and a string. And so this allows you to basically add type information to what is otherwise a sort of dynamically typed language, and then you can use that to do compile time checking. You can also create custom types, like down at the bottom here, we're declaring a type called year. We're saying that there's this concept called year, this type called year, and it's an integer. And so in that function there, def current age, year of birth, we know that year has to be an integer. So if you tried to pass something to it that wasn't an integer, that would be something the compiler could flag. There's also a notion of what's called behaviors. These are like kind of like abstract classes, in Java or something, where you can basically declare a set of functions that any other module that's basically implementing that behavior or adopting that behavior is obligated to implement. And so in this way, you can basically define some type, some module, and then have implementations of it that do different kinds of things, but they all have to behave basically the same way and have the same functions. There's also protocols. And I know I'm going through this fast, but we're going to run out of time if I don't. These are also another way of basically defining a type, a module called size with a function called size, and then for different kinds of arguments, for bit strings versus a map versus a tuple, the behavior or the way that it behaves and the way the calculation is done is slightly different. These are all mechanisms for adding this type checking kind of capability in if you want it. So then, what about the syntax of Elixir? Why do I say it's concise and modern? It's very Ruby-like, so if you've done any Ruby, you'll be surprised how similar it is. Ruby is well known for being very concise and very productive for developers. Elixir has a lot of interesting data types. It has all the kind of typical ones, but then it has these things like atoms and tuples and maps and ranges. And also this notion of a struct. So this module here that is just a module of Elixir code can have this thing called a struct, can define a struct, and basically it's essentially a map that has enforced names for the fields, and you can use it in all different kinds of ways, but it's a useful thing. This is one of the things I think is pretty cool about Elixir that I haven't seen in any other language. Maybe it exists elsewhere, but this notion of the pipeline operator. So pipelines are basically, these things where the output from one thing becomes the input to the next thing, and there's lots of examples of that in software that we build, but I haven't seen it at this level in the language. So in this example here at the top, we have this function called fix the name, and you pass a name in. And what we want to do is we want to trim the name, and then we want to replace any spaces in the name with a pipe, with a vertical bar, and then we want to uppercase the name. So basically we're going to take whatever name gets passed in, trim it, replace it, and uppercase it. So one way to write it is in this sort of, one step at a time kind of thing up above with all the variables. But then using the pipeline operator in Elixir, you get much cleaner code. So down below, we start with the name, which is passed in as an argument, and we pipe that to the trim function. And remember, in a pipeline, the pipeline operator, whatever the previous result of the previous expression was, will get passed in as the first argument to the next expression. So we start with name, that's the result of the previous expression. The next expression is string.trim. It takes one argument, which is the name. So the name will get passed in there. Then it will get, the name will get trimmed. The result of that will then get passed in as the first argument to replace. The replacement will happen, and then the result of that will get passed in as the first argument to upcase. So you can see how in a lot of cases you can make the code a lot more concise and easier to read in a lot of ways by using the pipeline operator. Another cool thing in Elixir, I think this is really cool, I've never seen this before, is pattern matching. So in Elixir, the equals operator is actually not assignment, it's actually matching and binding. So it does matching and binding. So basically down here in this example code on the bottom, the very first expression that I typed in was x equals 1. And what that does, as you can see, the 1 that got returned as the value, it basically binds the value 1 to the variable x. And then in the next line, I say 1 equals x. So you'd think that seems odd. I mean, like, that doesn't seem like you should be able to assign x to 1. And that's because you're not. The equal sign is actually matching. And so basically, what we're doing there is we're saying 1 equals x. And since x is bound to 1, the answer is basically true. If the answer was false, I would have gotten an error. So then in the next line, I bind the value 2 to the variable x, and then the next line, I say 3 equals x. Well, x is now bound to 2 in the previous step, and I'm saying 3 equals 2. And the answer is no, 3 doesn't equal 2. So I got an error, no match on the right-hand side because the value is 2 instead of 3. So you can see how matching, basically happens in Elixir here a little bit in the expressions. But you can also use this in really cool ways, like in function signature matching. So like in these guys, like let's take the one that's the lower example. You can see I have the same function 3 times. I have handle info, handle info, handle info. But in those 3 cases, the arguments are look slightly different. There's actually the same number of arguments in the first one and the second one and the third one. They all have 2 arguments. But in the first one, I've used what's called destructuring to pick out some things that I expect to occur in those arguments. And what happens is Elixir will go down through all of those different versions of the same function, and it will see which one is the first one that matches the incoming argument. So if the arguments coming in have basic cancel in them, then I'm going to get the second function, the version of the function is the one that actually executes. If it was basic cancel OK, I'm going to get the third version of the function that executes. You can also use pattern matching inside of functions. This is oftentimes used in place of a lot of if statements, if then else statements. So this is an example where this line of code that says user from auth, find or create, it's going to return some result. And those 2 things below that are in curly braces, OK, comma user and error, comma reason, those are the 2 possible answers or shapes of answers that I am expecting. So if the answer pattern matches to OK and user, then I'm going to run the code that's after the arrow there. Otherwise, if it matches up to error and something called reason, then I'm going to run the other code. So we use this pattern matching mechanism a lot in Elixir to do essentially what would otherwise be a lot of conditional logic. So that's another reason I think it's really concise and modern. So I'm going to run out of time for a demo if I don't move on. I wanted to say there's a site called hex.pm out there that's the package manager for Elixir and Erlang, where you can find tons and tons of packages, different libraries that you can use in your programs. It's all available for you just to download. There's like 13,000 packages available. It's kind of like a Maven repository in Java. There's a really great build tool that comes with Elixir that lets you generate application, generate new projects and compile and test and all those things. Good IDE support as well in a lot of the popular IDEs. And then I think I will pass over this one. I'm going to run out of time to talk about it. But Phoenix is a piece of framework, or is a framework within the Elixir world. That's their web application framework. And I'm going to show you some of that in the demo. But it's really high productivity and high performance. It's, I guess, pretty similar in a lot of ways to maybe something like Ruby on Rails, at least in terms of the productivity and so forth. It does live code reloading, so as you change code, it can automatically update without you having to restart it. It has really great tools in different kinds of components, and it offers some pretty sophisticated mechanisms like channels, which basically allow you to create essentially like WebSockets or these soft real-time communication channels between literally millions of connected clients for things like multiplayer games or IoT or whatever. And also presence, which is actually pretty hard, but I mean, like if you think about like a Slack or something like that, messaging in your iPhone or whatever, when somebody starts typing, the Slack client basically shows you that they're typing. And if they're online, it shows you that their little green light is on and it shows that they're online. That's the notion of presence. And that is built into Phoenix, and that's actually not a very easy thing to accomplish. And so that's a pretty valuable piece you can use for a lot of different reasons. So then the thing I wanted to demo and talk to you about too at the very end here is this thing called Phoenix Live View. So we've talked a lot about like all these sort of server side, high scale, high concurrency types of systems that you can build with Elixir. But you might be interested to know that by way of LiveView, you can also build user interface, and you can do that with a server rendered HTML framework. Basically, LiveView essentially tracks state on the server side in your application, and when certain things change, it re-renders only certain parts of your HTML, just like you would do with React or Angular or something like that. You can just change a very small part of your user interface. And that change, that impacted and regenerated HTML, gets pushed to the browser over basically a WebSocket. And then the browser view updates itself in the most efficient manner. It really only changes the part of the DOM that is the very smallest amount that needs to change. So you can build rich single-page applications without even writing JavaScript. Basically, you can write Elixir and still build these kinds of applications. So I'm going to demo that for you, and I'm going to pass over these other pieces. So let me flip over here, and I'm going to start a couple processes up. So in this shell right here, I'm starting up Rabbitmq, which is a message broker. And I'll explain to you what this application is in a second here. But I'm starting up basically 3 Elixir applications. And this is what they are going to do. So this is an example that we built at Blue River Systems Group to explore one of the really cool tools in the Elixir space called Broadway. And it basically generates sensor readings as if there was like an IoT sensor network out there. And it allows you to basically see the effect of those sensor messages on a LiveView user interface. So in my browser here, I'm going to open up the I am behind schedule, so I'm going to do this fast. So this is the LiveView user interface. This is all basically server rendered code. Over here, I have this other view that allows me to start up sensors. So you can see right now that I have this chart down here that's kind of shifting around, and this is CPU utilization. So I have these processes, or Elixir processes, like I talked about, running on the server. One of these things I wrote up, or that I started up, that are monitoring the CPU utilization on my machine. So the 8 cores that I basically 8 virtual cores. And nothing's happening in this pipeline, data processing pipeline yet. But as soon as I start up some sensors, you're going to start seeing data flowing basically from the simulated IoT manufacturing line over here, and these guys are going to start lighting up. And when that happens, just realize that I'm not touching this user interface. This is all happening completely on the server side. So I'm going to just go ahead and start up a bunch of processes here. So I've started up, I don't know, 11 processes or something, and this, as this guy operates, you can basically see the CPU utilization is changing. You can watch the messages per second. You can watch the color coding, which I won't explain right now what that means, but all of this is happening without basically ever touching, doing any round trips, and I have not written any JavaScript to make this happen. So this is all completely server-side rendered. This is the kind of thing that you can do with LiveView. Another example of it is a tool that comes with Phoenix, which is the Phoenix Live Dashboard. So this is also built in LiveView, and it has monitoring capability for all different kinds of aspects of your Phoenix application. I have a few others, but one I wanted to point you at just because it'll give you an opportunity to play with it yourself. There's this app called GeoRacer, georacer.io. You might bookmark it. Go visit it on your mobile device, and you can play this game called GeoRacer on it, and it is a Phoenix Live View app. And just remember, when you're using it, it's everything that's happening is server-side rendered, and there's no JavaScript that the programmer wrote that's in the game. Okay, so with that, I'm gonna just put up this list of resources, and I guess we'll go to question and answer because I know I'm a little bit over time already. I can show more demo if you want, or we can talk through some questions, however you guys want to spend the last like 10 minutes that we have.
Thanks so much for that. We will go ahead and open the floor for questions, and our tech team on the backside is sending those over to me as they come in. So if you have another demo to share, please feel free to do that, and I'll maybe ping in with questions as they come or if they come.
Sure. One other one that I could show you. This is one called, oh, I don't have that one started. Just one sec, let me go to this other, let's see. This is a flight simulator. So this is actually written in live view as well. And so I can basically fly a plane. I can start once it paints. So I can basically start flying, and I think my machine is running slow because I have the Telluride thing running, but all of this, all these dials, this graphical user interface, the map, all of this is basically server-side rendered. So this is another example. There's a website I would mention if you're interested in this stuff called Phoenix Frenzy, and I have the site listed here. It was a competition that they did for people who wanted to build a Phoenix Live View app and compete against others. So the GeoRacer was the one that won, but there's a number of other ones out there that you can explore, and you can actually go look at all the code if you're interested in that as too. But maybe since there are people here that are just starting out in programming, well, how do you ever get started with Elixir? I mean, I would go, here's where I would go. I would go to the Elixir Lang website, elixir-lang.org. They have a getting started. It goes through all of the basic stuff, like what are the data types, really just like down the line, all the basics that you would need to know. Lots of examples you can run. They show you how to install it. They show you step by step everything you need to do. And then I know these two different sites here, Elixir School and Tutorials Point, both of them have a ton of tutorial material that you can run, that you can go through as well. So these three sites, I think, are a wealth of information. There definitely are courses on Udemy for Elixir and Phoenix as well, and probably other places. And then there are good books. I mean, the two that I like the best are these two, Elixir in Action and Programming Phoenix. They may be a little more advanced than you want just starting out. I think if you really want to get started, these tutorial sites are a great place to start. So I know somebody asked the question, somebody had a question about what kind of jobs use this language. And so early in my introduction, I talked about software product companies and IT companies. And I want to say that Elixir is something you could use in both of those contexts. So what kind of job could you get? Well, as a software developer, you could be a full stack developer who's doing front end and back end work. And you could be working in a software product company, like a company that is selling, running an e-commerce site, or maybe is selling some kind of a tool that people use to do software development, like Rally, agile software development kind of tool or something. Just about anything that is a software product you could build in Elixir. And then in IT, meaning in large organizations where they just have a technology department that has to build systems for their business people to do certain kinds of things to support their business, you could definitely use Elixir for that too. You could build web applications, you could build data processing systems, any of those kinds of things. So I think as far as software development jobs go, you could specialize as a server-side developer, or you could be a full-stack developer. Either way, I think Elixir is a perfectly good language to use. It's not as mainstream, and the next webinar is gonna talk about that topic. I think Elixir is not as mainstream as some of the other languages, but it is, I think, a pretty high demand language at this point. Are there any other questions?
Awesome. Well, I know that we had just a question on the best way to contact you for follow-up or a way to connect with you. And I know we'll share that information if you could provide it. Perfect. Looks like it's there.
Yeah, I mean, so you're welcome to email me. You can go to my website or my LinkedIn page. If you just search for Dave Muirhead, you'll find me. I think I'm linked from my website as well. But yeah, call me or email me, or you can reach out to me on the SE Code Slack is fine too. And link in with me. I'd love to know who's working on stuff in the area and get connected up with you guys. So please do link in with me.
Thank you so much, Dave, and thank you for being here with us this evening. To everyone who is watching, this will live on our SE Codes YouTube page, so feel free to come back and explore more of our videos, but also refresh in this video as well. For all of our folks watching, I hope you have a wonderful evening. Dave, thank you so much again. Dave is also a mentor in our program, so another plug for you to get connected with our program and have access to fantastic mentors like Dave. And with that, I will wrap up. I know we may hang on for just a bit if there are any additional questions, but if not, thank you so much for joining us. And Dave, thank you again for sharing your time and talent with us.
Yeah, thanks for the opportunity. I appreciate it.